Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain about IB Chemistry Paper 1 Standard Level Prediction question. It's not 100% guaranteed this question will be appear in the exam, but you can also take this as a mock test to check whether you are ready for the exam or to check what kind of topic that you're still struggling with, so you can go back and then do revision. It is highly recommended for you to do these questions because it follows the IB exam style question, include or involving some of the difficult question or medium and easy question. And if you find this video is helpful, please don't forget to subscribe and let your other friend knows about my channel to support me. And now let's get started. 0.04 moles of magnesium nitrate is dissolved in 500 centimeter cube of water. What is the resulting concentration of all ions in solution? When Mg NO3 2 dissociates, it will produce Mg2 plus and 2NO3 minus. So moles and volumes are known, so we can calculate concentration, which is N divided by V. So 0.04 divided by 0.5, so you get 0.08, and we've got 3 moles of ions here, so times 3, then it will be 0.24. So the answer is A. 36 centimeter cube of 1 molar solution of copper nitrate reacts with 0.54 gram of aluminum. Here we can calculate mole of copper nitrate, so NC times V, which is 1 times 0.036 decimeter cube, which is 0.036 mole. And for aluminum, we've got mass, so we can calculate the mole divided by its relative atomic mass, which is 27, then you get 0.02. Okay, so to calculate mole of copper metal, we need to refer to the limiting reactant. So now here we've got to choose the limiting reactant, we need to choose the one that will be used up first. For 0.02 mole of Al, it will be 0.01 mole for 1 Al, and this one it will be 0.012 for 1 CuNO3 2. Therefore Al will be used up, so we refer to the Al. This is the limiting reactant. So to calculate mole of Cu, 3 divided by 2 mole ratio times 0.02, which is 0.03 mole Cu. A molecule has the empirical formula CH2, so this 12 plus 2, which is 14, and a molecular mass of 56.124 gram per mole, which is not possible structure for this molecule. So we need to find the molecular mass, so 56.124 divided by 14, so you get 4. Okay, so now CH2 times 4, it will be C4H8. So we need to find out which one is not C4H8. This one, C4H8, this one also, and this one also, but not for this one. This one is C4H123456. So the answer is D. 6 gram of ethane gas is placed in a flexible container at STP. The conditions are then changed to a new pressure 200,000 Pascal and new temperature of 546 Kelvin. At STP, the pressure is 100 kilopascal and 273 Kelvin. And here is 200 kilopascal, so the pressure is doubled and the temperature is also doubled. What is the new volume of the container after equilibrating to the new temperature and pressure? The molar volume is 22.7 decimeter cube. Since we've got the mass and the molar volume, so we can calculate the volume, which is N times Vm. So N, that would be 6 divided by 30.07 molecular mass of ethane times 22.7. So you've got 4.54 decimeter cube. So this will be initial volume. Okay. So because there are two volumes, there are two temperature and two pressures as well. So we can use combined gas law. P1 V1 divided by T1, P2 times V2 divided by T2. Okay, so we need to find second volume. Okay, new volume. So V2, it's P1 V1 T2 divided by P2 and then T1. The pressure is double, the temperature is double, so now we can plot V2 P as a pressure, V1 is the question, T2 it's double, so 2T, pressure is double, so 2P, and then temperature. So now we can remove or eliminate T, eliminate P, and then 2 as well. So left V2 equal to V1. So the volume remains the same or unchanged. The answer will be 4.54. Which of the following species has the highest number of unpaired electron? Cr with the electron number of 24. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Remember the rules of half fill, and full fill. So this one we need to change it to be AR. Okay, this will be AR. 4s1, 3d5. So in the diagram orbital, that will be 1, 2, 3, 4, 5. 5 unpaired electrons. For Cr2 plus, that would be remove 2 from this, so it will be 3d4. Cr3 plus would be, so Ar 3d4, this one Ar 3d3, and this one will be Ar. So this is not the answer. This is only 3 pair of electron. This one is 4 pair of 3 unpair of electron. This one 4 unpair electron. So has the highest number of unpaired electron. That would be Cr. Which mass spectra would you expect for magnesium molecular mass 24.3? So let's calculate this. That would be 24 times 80%, which is 0.8, plus 25 times 0.1, plus 26 times 0.1, which is 24.3. This is the answer. Let's check for B. That would be 24 times 0.5 plus 25 times 0.3 plus 26 times 0.2 would be 24.7. No. This one would be 24 times 0.9 plus 26 times 0.1. You've got 24.2. Then no. And this one, 24 times 0.6 plus 25 times 0.4, which is 24.4. Okay, the answer is A. What is the sum of all coefficients when the equation below is balanced? Here will be 2, here will be 3, here will be 2, and this one will be 1. Total is 8. Which give the correct reason and trend in metallic character down group 17? When you go down a group, it's easier to remove the electron. As the number of electron increases, number of shells will increase as well. So the atomic radius increases. It will be easier to remove the electron or to lose the electron. It promotes metallic behavior, so increases. And because of it's easier to remove the electron as the atomic radius increases, it will lower the ionization energy to remove the electron. So the ionization energy decreases. The answer is C. When add to water, which of the following compounds will result in a solution with a pH below 7, which is acid? MgO is basic oxide. It comes from group 2. So it's basic oxide, pH bigger than 7. Al2O3 is amphoteric. So it's neutral. So pH around 7. Now it's left Si and P for SiO2 and P4O7. Si, it's not that really acidic, slightly acidic because it comes from nonmetal, but P is more nonmetal. So the one that is more acidic, which is pH below than 7, would be D, because this is acidic oxide. An element has the electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d7. So we've got this as the last one, 4s2, 3d7. Which of the below gives this element the correct number of energy level, block, and group? So 4 is the highest energy level, so 4. And D of it fills D subshell, so it's not S but D. And then it has 9 electron, so valence electron is 9, so it is a group 9. Carbonate salts are sometimes used as raising agents in cakes. Which of the following is the correct Lewis structure of the carbonate ion? CO3 2-. So we've got only 3O, so this one is incorrect. And for A and B are the answer because they are the same. So either A or C. Potassium and calcium are both solids at room temperature. Which of the following statement is true? Okay, for metal melting point, they are determined by ion size, charge, and electron delocalization. Potassium, it comes from group 1. This is +1, and this one +2. Okay, and calcium has higher or bigger proton number compared to potassium. So the electrostatic force is higher in the calcium compared to potassium with the delocalized electron. Okay, so +1 charge, which is potassium, with 1 valence electron has lower melting point compared to Ca with the +2 charge and smaller atomic radius, and also it has 2 valence electron, so resulting in a stronger attraction to the C of the delocalized electron. As I said, metal melting point determined by the size, charge, and electron delocalization. It has more electron delocalization and it has higher charge. Therefore, calcium melts at higher temperature because more valence electrons are delocalized. Ammonium nitrate is a compound commonly used in fertilizer and explosives. What is the bond angle of the cation in ammonium nitrate? So cation, ammonium nitrate, cation will be NH4+. So this will be, okay, it's 4 domain, so it's tetrahedral. If it's tetrahedral, the bond angle is 109.5 degrees. The structural formula of boron BH3 is shown. Which of the following statements are true? The electron domain is 3, so it's trigonal planar, correct? The bonds in boron are dative covalent coordination bond. There is no dative covalent or coordination bond. The boron atom in boron is electron deficient. It is true because BH3 still can accept a pair of electrons, for example from H2O that has a lone pair. So that lone pair, 2 electrons from H2O, will form a bond with BH3, forming a dative covalent bond, or maybe from halogen ion like Cl minus. So a pair of electrons from Cl minus will form a bond with BH3, forming a dative covalent bond. So the answer is 1 and 3 only. The structural formulas of 3 organic compounds 1, 2, 3 are shown. This one has polar bond, so it's dipole force, and this one has no polar bond, so it has London dispersion force, and this one has hydrogen bonding. Definitely this one will have highest boiling point. In which of the following are the compounds listed in order of decreasing boiling point? So this is the strongest, and then go to here, and then here. So the answer is 3, 1, and 2. Ozone O3 can be broken down by the absorption of ultraviolet light. An enthalpy cycle diagram for this reaction is shown. So O3 gas produce O2 gas and O gas. Okay, so delta HR is delta HF product minus reactant. We don't use oxygen because it is in the standard state, so we've got only product, which is delta HFO minus delta HF oxygen, which is D. The accurate enthalpy change for the reaction of aqueous hydrochloric acid with solid sodium carbonate is delta H equal to negative 36 kilojoule per mole. So this is the accepted value or the literature value. A student tried to determine delta H by adding 3 grams of sodium carbonate to 100 centimeter cube aqueous hydrochloric acid and measure the temperature and get negative 38 kilojoule per mole as the delta H experimental value. And they recorded the data right here. Which of the following could account for the difference between delta H accepted value and experimental value? As you can see, the numbers are not that very much difference. It's only 2 kilojoule per mole. Therefore, there is slight small error here. So if we see the option D, the solution lost heat to the surroundings during the reaction. If there is a heat loss to the surrounding, it means delta H will be very high, not 2.6. So the delta H experimental would be much bigger than this. It's more negative, and so it's gonna be far from negative 36 kilojoule per mole. So D is not the answer. And then for A, the solution density was greater than 1 gram per centimeter cube. So it means that the students record wrong for density number. And you know, to find D, it's mass over volume. So if density is 1, the mass will be very small, but the mass here is 100, therefore A also not the answer. The solution mass was increased by the addition of the sodium carbonate. If the mass increase, of course, delta H experiment also will be higher. So it's going to be more far from the negative 36 kilojoule per mole. So this is not also the answer. But the heat capacity was less than 4.186. That would be the case. Because if mass and temperature are correct, so the number of heat capacity influence this experiment. If the heat capacity is lower, so delta H will be close to the negative 36 kilojoule per mole. Given enthalpy diagrams for reaction A, B, and C, which of the following statements is correct? Diagrams B and C could represent a catalyst add to reaction A. As you can see here, the activation energy, decreases, but delta H also change. Adding catalyst adding the catalyst will not change the enthalpy. They only lowering the activation energy. But as you can see here, the enthalpy of the B and C are not the same with A. Therefore, B and C cannot be represent a catalyst add to reaction A. Reaction A has the greatest activation energy. Correct? Because as you can see here, and here, it is much higher. All reactions are exothermic. This one exothermic. This one endothermic. Okay, increase in enthalpy. This one exothermic. So only 2. In experiment, nitric acid is reacted with sodium hydroxide to form sodium nitrate and water. The table below showed the concentration of nitric acid measured at different time intervals. The rate of the reaction is equal to delta concentration divided by delta time, which is 0.2 minus 0.45 divided by 0.5 minus 0, which is 0.5. In the reaction below, iron speeds up the reaction. So iron is catalyst and remains chemically unchanged at the end of the reaction. It's not consumed. Okay, so all statements below are true for the role of iron in the above reaction, except iron increase the average kinetic energy of the reactant. Iron just lower the activation energy. Okay, so it provides alternative pathway. It does not affect the yield because it's not consumed, and then lower the activation energy. So the one that is incorrect is C. What will happen to the value of Kc of an equilibrium yield of HCO3 minus if the volume of the reaction vessel is decreased? So when the pressure and volume relationship is the inversely proportional, it means if volume decrease, pressure increase. Okay, if pressure increase, it will shift to the number of fewer gas molecule or mole of gas. Here, as you can see on the right side, there is no molecule that is a gas, but here there is CO2, so on. So this is fewer products has fewer gas molecule compared to the reactant, so it will shift to right. When it shifts to right, the yield will increase because product will increase. But Kc remains the same because Kc only change with temperature, not pressure or volume. PCl3 and Cl2 gases are added to a reaction vessel and allowed to reach equilibrium. What is the relationship between the concentration of PCl3 and PCl5 at equilibrium with Kc equal to 1? The equation would be PCl5, concentration of PCl5 divided by concentration of PCl3 and Cl2. If we assume that mole of PCl3 equal to mole of Cl2, therefore volume also will be the same. So this will give a new relationship which is concentration of PCl3 equal to the concentration of Cl2. So we can do we can rewrite the equation, which is PCl5 equal to concentration of PCl3 because they are the same. So this will be squared, which is 1. So Kc equal to concentration of PCl5 divided by concentration of PCl3 squared equal to 1. Therefore, concentration of PCl3 squared equal to concentration of PCl5. So concentration of PCl3 will be square root of concentration of PCl5. Aluminum oxide undergoes the following reaction. Okay, aluminum oxide react with base and then acid. Which of the following is the best description of aluminum oxide? In this reaction, when aluminum oxide as an acid react with strong base, there is no proton transfer. So aluminum oxide is just considered as an acid because it reacts with strong base. But for this reaction, HCl as a strong acid donates its proton to Al2O3. Therefore, we can consider Al2O3 as a Bronsted-Lowry base because accept proton. So the answer will be C, a Bronsted-Lowry base but not Bronsted-Lowry acid. Remember, Al2O3 is amphoteric. It means it's just able to act as an acid or base, but it's not amphiprotic, which can donate and accept proton. Using the following table of indicators, what could be pH of an unknown solution with the following result? Methyl orange with the pH range 3.1 to 4.4, red and orange. It gives orange color. It means pH bigger than 4.4. And for this one, it produced blue color. It means bigger than 5.4. But for this one, it gives colorless. So it means smaller than 8.3. Therefore, it's 6.5. The below diagram shows an electrolytic cell at which electrode will bromine form and what is the process taking place there. So panic, positive anode, negative cathode. Anode experience oxidation, cathode always experience reduction. Now we've got PbBr2. So there is Pb2 plus and Br minus. Pb2 plus will go to cathode because it's negative electrode. So cation will attract to the negative electrode, and Br minus to the positive electrode. So this positive will be anode, negative will be cathode. Anode will be anode will be Br minus. Okay, Br minus. This one will be Pb2 plus. So the answer will be B, at which electrode will bromine form, electrode S, and its oxidation because anode oxidation. The Winkler redox titration method can determine dissolved oxygen levels. Which statement best describes the redox chemistry which occurs in step 1 of the titration shown below? This will be +2, this will be 0, and this will be -4 because oxygen is -2 times 2, and this will be +4. So Mn +2 to +4. Oxidation, if it's oxidation, it's reducing agent. If it's reduction, it is oxidizing agent. And for oxygen, this -2 this plus 2. Okay, for oxygen, 0 to -2, reduction. So the answer is D. Mn2 plus acts as the reducing agent and oxygen is reduced. The diagram below shows a Daniell cell or voltaic cell. Zinc is more reactive than copper. If it's more reactive, then this one will experience oxidation, lose electron. And copper will experience reduction, gain electron. Oxidation always at the anode, reduction always at the cathode. When the cell is operating, which statement about the ions in the cell is correct? So oxidation lose the electron, so Zn will lose the electron. This one will gain the electron. So positive ion in the salt bridge diffuse into the copper half cell. Okay, when Zn lose electron, so this will produce a lot Zn2 plus. So it becomes 2 positive. Okay, the electron will go towards this electrode. So many electron. Many electron, it will be 2 negative. 2 negative. So salt bridge, it has cations and anion. So cations will go towards the negative area to neutralize them. So cation, okay, positive ion will go towards here. Anion, which is negative ion, will go towards here because this area is too positive, this area is too negative. So positive ions in the salt bridge diffuse into the copper half cell. Correct. Positive ions diffuse into zinc? No, because it's already positive. So it cannot be 2 more positive. Zinc 2 plus ions are deposited at the zinc electrode? No. It should it's not deposit here, but it produce. The concentration of Cu2 plus ions increases in the copper half cell? No, because it gains the electron, so it will reduce, producing copper. Which of the following groups of molecules are all belong to the same homologous series? Okay, if we see here, this one, CHO, aldehyde. This is aldehyde. This one, O, ketone. Okay, this one, CHO, sorry, this is also aldehyde. This is also aldehyde because CHO, and this is also aldehyde, CHO. Okay, so the answer is A because it has the same functional group. But let's check B. This one will be alkene. This one, alkene as well, because you see CH here and CH here, so it will be like this. And this one, CCH, alkyne. Okay, and for this one, ketone, because C double bond O, this one. Okay, and this one, CHO, aldehyde. This one, ketone again. No, not the same functional group. This one, alcohol. This one, aldehyde. And this one, aldehyde. So homologous series needs to have the same functional group, which is A, aldehyde, aldehyde, and aldehyde. Which set of molecules are from the same homologous series and correctly arranged in order of increasing boiling point? Homologous series. Ethine, ethene, ethane. No, it's not homologous series because they're not coming from the same functional group. Butanol, propanol, pentanol, homologous series because it has it is all alcohol. Propane, butane, pentane is this all alkane. Butanol, ethanol, hexanol also all are aldehyde. But the problem is in order of increasing boiling point. The longer change, the stronger London dispersion force. So longer change, higher boiling point. So here, butanol 4C, propanol 3C, pentanol 5C, not in the order, not the answer. Butanol, 4C, ethanol 2C, hexanol 6C, not in the order. But now, dimethyl propane, methyl butane, and pentane. Dimethyl propane, C, 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 and then C. You can just add CH3, CH3, CH3. And then methyl butane, C, okay, and then C. You can add CH3, CH3, CH2, CH2, CH3, and then pentane, 1, 2, 3, 4, 5. Straight change, 1 branch, 2 branches. The more branches, the less surface area, so the less London dispersion force. So the highest London dispersion force is the straight change. Therefore, increasing the boiling point from here and then increase to methylbutane and then pentane. The answer is C, and they're all alkane. The oxidation of propan-1-ol is a two-stage process. Each state forms a different product. Propanol is the primary alcohol. When it is oxidized, first it will produce aldehyde, which is propanol, and if you oxidize again, will produce propanoic acid. The answer is D. Alright, that's all for the explanation for the predicted question for Chemistry Paper 1 Standard Level. Again, I repeat, it is not 100% guaranteed that this question will appear in the exam, but you can take this as a mock test to check whether you are ready for the exam or to investigate what kind of topic that you're still struggling with, because this question followed the exam style IB question. So it is highly recommended for you to do this question. And again, if you find this video is helpful for your exam preparation or revision, don't forget to subscribe and let your other friends know about my channel to support me. Bye for now.